Hey kids, so a bit today, um, just talking about um, what I need. Right now, I'm missing a lot of our minor assessments. These are our lab grades. I know some people have turned them in paper. I'm still grading those. Um, But I want to talk about how we are going to submit these when you are done. The second lab is due today. I do need you to upload that. Let me show you how to do that. This works for the other one too when you finish on this. We did minor assessment synthesis of magnesium. That was on Wednesday of last week and Tuesday. We did most of it on Wednesday. To submit this, all you have to do is click Start Assignment, okay? Um, just record, upload media. Here you can take a picture of your work, okay? Your Chromebooks will work, your phone will work. Literally any way you want to do this works. Just try to make it as easy as possible. Take a picture of it. I'll be able to read it. If it's multiple pages, you can just click start recording and just boop, flip it. Easy, okay? Now it's lagging because I have two videos going on, but it'll take a little video of whatever you do, okay? So should be really easy to submit. Any of your notes will be done the exact same way. We're going to talk about that as we get to that. Second thing, I'm going to leave aside. I'm not going to submit that to myself. Is test corrections. Test corrections are available for students who have finished their exam. I have gotten Danny's permission to show you how to do them, okay? So this will be using Danny's work. First thing you're going to do is you're going to go to Home, click on AP Classroom. This is the fastest way, okay? This is literally it's on Canvas. Just click on the picture. You're going to type in your password. Whatever my password is, I don't remember. Boop. Luckily, the computer does. You're going to go to your chemistry. Now for this, I think I'm already logged in as Danny. This is what Danny sees. All he needs to do is go down on this first course guide, Unit 1. You should have a progress check. It'll start looking like this. You won't be able to see anything. Just click on it. It'll pop open your score. Speaking of the score, if you're in dark green, you're falling within 4 and 5 range, which means that any university will take your score and you'll get college credit. If you're in light green, you're right on the edge. You're a 3, okay? 3s, most colleges are going to take you. Not every college, not Harvard, not Yale, not any of the Ivy Leagues, but not Vanderbilt. A lot of colleges will accept your score for it. If you're yellow, this is a 2, and if you're this dark gold, you're a 1. Is how you do it. Now, to do our test correction, it's going to be super easy, okay? You're going to open up your AP Classroom. Just click on it. You should see your topic skills, content and skill performance, how you're doing. If you want to go into a deep dive, saying how much you know, you should only have Unit 1 so far. Danny's at a 79%, which does put him in the 4 range for his so far in this class. So if he had to take the test tomorrow based off Unit 1, he would get a 4. Okay. Now he's going to go to questions. Now, these question area will tell you literally everything you got right or wrong. If you got right something by luck, then go check it. You know them better than I do. The only ones I worry about is the ones you got wrong. As I can see, just through a quick data analysis, most of the ones that Danny missed, he did really, really fast. So look, you got 8 seconds. That's super fast. You got 34 seconds, super fast. So maybe I'll just tell Danny to slow down a little bit. Remember, your average question length for the AP Chemistry exam should be 1.5 minutes to 2 minutes per question. So some of these, too long, 3 minutes and 34 seconds. He needs to speed that up, but he can slow down for some of these other missing questions. Take your 2 minutes. 8 seconds, way too fast. So And I can see that he only spent 40 minutes when he had 60. So he had some extra time to use. That's just some quick data analysis. That is not part of the test corrections. For test questions, I want you to go to the question that you missed, and it'll tell you what you missed. It'll tell you why you missed it, and it'll tell you the correct answer. So Danny picked 91 AMU. Okay, this is incorrect. This is the mass spectrum. To find the mass spectrum, what he needed to do was he needed to do 50 times 90 plus, this looks like, I don't know, 10, 20. This is 20 times 92. Looks like about 15 times 91. And just add them all up. 20 times 94. Looks like 5 times 96. Add them all up, you'll get an answer, okay? The answer apparently here is 91. This is just an estimate. I'm not sure. I didn't have Danny's paper in front of me. But what he needs to do is either on paper or on a Google Doc. He can go to a Google document. I mistyped it, of course. And he can just tell me question 1. I need the right answer. So the right answer is B, I think. Or was it A? I don't remember. The right answer is B. Oh, wait. Yeah, the right answer is B. That will have a check mark next to it. He picked A. And the answer is B. The right answer is B. Because my formula for atomic mass is the AMU is the sum of the percents multiplied by the mass. Okay, quick explanation. And honestly, these give you the explanation. I don't want you to copy and paste, put in your own word, but I read it and then I posted it on the Google Docs. He's going to go through every one of these. This was question 4. So make sure you have your question numbers here so I know what to look at. Question 4, he has the right answer, and he's going to go through and do all of those questions. Now, that's MCQ. You have 2 separate exams. I also expect you to do this for free response, if you wish the full credit. If you don't want the half credit back, then that's your personal preference. I won't give it to you. You don't turn this in. I would really suggest it, though. Let's go back to... So, Danny can go back to results, course guide. He's going to go back. Now he's going to look at FRQ. FRQ, he got a 6 out of 8. This is a high 3 or a low 4. It's a 75%, which does fall in that range where it could be either, depending on the year. He's going to go find the ones he missed. He missed Part A and Part B. So, for Part A, it even gives you an explanation. So again, it gives you the explanation. It gives you that you missed it. Okay? I'll tell you, a lot of people miss these 2 questions. A lot of people used the periodic table for an explanation. This is not enough. In fact, if you go back to my notes, I have in large bold words. You cannot use the periodic table as justification for an answer. If the question is asking for justification, you need to tell me why based off the science, not on a table that we use, okay? The science indicates what, okay? Why is the ionization energy left? Not because it's on the periodic table. The elements aren't on the periodic table. Tell me why, okay? A lot of people miss A and B because we're using the periodic table as justification, which can never be the right answer. You'll find the same on the AP exam. Do not use the periodic table as an explanation. Okay, so that's test corrections. That again, whoops, gets submitted. Here. You're going to go down. There's test corrections for Unit 1. You'll open it up, same way as you did the other one. Click Start. I have a whole bunch of ways you can turn it in. You can turn it in text right here. You can make your own Google Doc. Google Drive is right here. You can, again, record and upload paper if you took a picture of it, take a picture of it, submit it to me. However you want to do it is fine. It is due 1 week from tomorrow, which is a Tuesday. So let me know if you need any help. It will give you half credit back for both of those exams. So if you got a 70, that'd become an 85. If you got a 60, that would be... Wait, no. 70 would be an 85, right? Then 60 would be a 75. Would be an 80. A 60 would be an 80. So it does help the people who scored worse than the people who scored better, but just realize they're also doing more work. So it's kind of, I don't know if it's fair, but it kind of, if you do work, you're going to get credit in my class. Now, okay, so we talked about minor assessments. We have talked about the test corrections. Now we're actually getting to the heart of the matter. We're going to move into our first unit. The second unit. It's unit number 2. Going to unit 2. We're on 2.1 types of bonds. This will be your notes. There is a paper copy of this. If you wish to do it digital, it's here. If you wish to do it on paper, it's on paper. Either way is perfectly fine by me. That's why I have it available. It will be submitted by the end of class. Let me go to my notes. Before I forget, there is a reading as well, 2.1. I'm not going to grade these until I get back. I really suggest you do these. They are all virtual. If you want a paper copy, ask Miss Rucker, see if she can help you out. Unfortunately, I'm not near the printer, so I just have it all digital. And we're already printing a lot for all the classes, so, and I'm not going to ask more of anybody else. So this is the reading for today. You'll have one based off, every day has a note, has a reading. Again, I'm not grading these. I'm not grading your annotations for these. I would heavily suggest you read it, especially if you want that 4 or 5. They're never going to be that much. There may be 5 to 10 pages tops, except for the rare 30, 40 pages I assigned you once. I mean, again, it's really up to you. This is heavily suggested, not enforced, at least until I get back. When I get back, I'll start grading them again. But again, it's going to be, I'm not going to ask you to take pictures of 30 pages of your notes. You're already taking enough pictures. The things I am going to ask you to do is make sure you go and do your videos, okay? We're going to log in, do our videos. You have 2.1 videos are due today. I'm going to be checking those. Let's get to our notes. I know it's already been a minute. Okay, we're on week 5, day 1. Okay, agenda today. Do now. We have some notes, 2.1. We have our I do, our we do, our you do, and a little exit slip. Our lesson objective today is I can explain the relationship between the type of bonding and the properties of the elements participating in the bond. Do now. I showed you how to do your test corrections. Tell me how many questions you need to do for your test corrections on your do now for me, please. I decided not to send you out an email, just ran out of time. But it is all available on AP Classroom. Okay, electronegativity. Electronegativity is something we talked about in Unit 1 as well. Realize we gotta know what this is. It's important for oxidation numbers, and it's important for the periodic table trends. It's important for everything we do in class. Electronegativity is the ability of an atom to attract shared electrons. Coulomb's law, again, we bring this up because, again, it is important. It's a reoccurring theme. This is the attractive force increases with greater charge and decreases with increased distance. Our formula for this was F is equal to Q1 multiplied by Q2 divided by R squared. This is Coulomb's law. It's not equal to, it's proportional. So force is proportional to Q1 times Q2 divided by R squared. Trends in our periodic table. As you go down a group, electronegativity decreases due to increased distance from the nucleus, more electron shielding. Now, again, this is justification for our questions. When you explain something, you're not telling me that it exists. You tell me why it exists. So instead of saying, oh, it increases as you go down the periodic table, but why? Well, it's decreasing because, number one, you're further away from the nucleus. Perfectly accurate. Some people posted that, which was accurate. And B, it has more electron shielding. Okay? Nuclear shielding. Those are the two reasons that electronegativity decreases. Now, as across from a period, electronegativity increases as atomic radius decreases and effective nuclear charge increases. So the nuclear charge is going up, which increases electronegativity. Atomic radius decreases, it gets smaller, which means electronegativity also goes up. Fluorine is our most electronegative element, which has a small radius and minimal electron shielding, leading to a strong attraction for shared electrons. I'm going to show a picture of fluorine. Here's fluorine. Fluorine is the most electronegative. Here is neon's potential shell. Fluorine is right next to neon. This is the non-shielding outer shell. This is the helium-filled shell inside. You can see that there is so close to being neon. All atoms want to be their corresponding noble gas. So fluorine wants to be neon, chlorine wants to be argon. Whatever noble gas is on the end of that table, everybody in that element probably wants to be it. Okay? That row. We have a table I need you to fill out. This is electronegativity for compounds. So we've been talking about atoms a lot. We're moving into compounds for Unit 2. Compounds are how most elements are. Most elements aren't just sitting around by themselves. Most elements are some sort of bond with somebody else. In a nonpolar covalent bond, you have an equal sharing of electrons. There is no bond dipole moment. An electronegativity difference is less than 0.5 for those atoms. Now, I know we haven't talked about bond dipole moment. Hopefully this is a little bit familiar from general chemistry. A bond dipole moment means that there is a partial charge, okay? Or full charge. A charge is, think of it like a magnet. Magnets have dipoles. They have a north pole and a south pole. So do compounds. A lot of compounds have poles. They have a south pole and a north pole. They attract opposites. They repel similars, just like atoms. Magnets and atoms, same thing. So here we have a polar covalent bond. It is unequal sharing of electrons. You see that the electrons are mostly going to be here on my visual. You have a bond dipole moment of a partial. So maybe it's not as strong as a north and a south pole. It might be a partial south pole. It might be a partial north pole. This makes them weaker, but they still exist. Our electronegativity difference here is between 0.5 to 1.7. Finally, ionic. Ionic is when you completely have transferred your electrons. You've just given them away. All the electrons are here at B. Okay? You create a positive and a negative charge. Your electronegativity difference between your atoms should be over 1.7. This only happens between great electronegativity difference, between fluorine and sodium, chlorine and chlorine and barium. Okay, big differences. Okay, electronegativity. Here's some examples. We have H bonding with H. There is no difference. Hydrogen is the same electronegativity. It shares electrons just as much as another atom of hydrogen. They're the same atom. All electrons get shared equally. This is a covalent nonpolar bond. Okay? Nonpolar covalent. H, Br. H and Br. There is a slight difference. If we went and looked up our electronegativity values, you would see a small difference between hydrogen and bromine. Bromine still wants the electrons more than hydrogen does. It has a higher electronegativity, okay? This will create a polar covalent bond. Bromine is partially negative. It has taken more electrons. Hydrogen is slightly positive. It has let go of its electrons a little bit. Finally, NaCl, sodium chloride. Sodium chloride, for the rest of this is the hydronium compound. This is H2. This is hydrobromic acid. And this is sodium chloride. You can determine if a substance will have ionic interaction by looking at the types of atoms involved. If the substance is made up of a metal and a nonmetal, it will likely form an ionic bond, especially if there's a large difference in electronegativities. Okay, ionic, first type of bond. Ionic bonds occur between metals and nonmetal atoms when they lose or gain electrons to form ions. This type of attraction is a Coulombic or electrostatic attraction. They are attracted to each other because of their charges. Plus and a minus, a north and a south. They are attracted to each other because they are opposites. Opposites attract. The ionic bonds are stronger when the charges are larger, the ions are smaller. This is explained by our Coulomb's law. F is proportional to Q1 multiplied by Q2 divided by the radius squared. Coulomb's law. Ionic properties. If you have an ionic compound, you will form a crystal. You'll have high melting and boiling points. You're going to be hard. You're going to be brittle, which means you can break apart easily. You conduct electricity when you dissolve. If I put salt in water, salt water will conduct electricity. And when molten, if you melt sodium chloride, it will conduct electricity. They are also good insulators as solids. So as long as they haven't dissolved or melted, they're good insulators. Metals, second type of bond. Metallic bonding occurs between metal atoms. It can be just one type of metal, a pure substance, or a different type of metal, a mixture called an alloy. The metallic attractions are due to multiple metallic cations. Cations is a positive charge, cation is a positively charged atom. It is positively charged to a delocalized, which means everywhere, sea of valence electrons. So in metals, electrons just flow everywhere. The IMF is stronger when there are multiple smaller metallic cations and when there are more valence electrons. Okay? The IMF is stronger when there are smaller cations. There are more electrons. You have more charge. Here's a picture of a metal. You have all of your cations, positive metal ions, and around them is just a flood of electrons. Okay? Lots of electrons. This is a sea of moving electrons. So our metallic properties, all metals will have these. They are shiny. Gold is shiny. Metals are shiny. Sodium's shiny. Calcium's shiny. Any metal is shiny. It has luster. It attracts light and repels it. It's malleable and ductile. I can bend it. Okay? Maybe not with my hands. You can't grab a steel bar and just go whomp unless you're super strong. But it will bend. It won't just break even if you apply force. It conducts heat and electricity. This is because of my flow of electrons, okay? These electrons allow electricity, which is just electrons, to flow. Metallic oxides are basic and ionic, okay? So when you attach a metal to oxygen, So magnesium oxide or sodium oxide or what else I've talked to? Barium oxide. Any oxide that is made with a metal are basic and ionic. Okay? They lose electrons to form cations. So metals like to lose electrons. They let them go very easily. Nonmetals. My personal favorite. Is what I'm made of. Nonmetals are non-lustrous. They don't shine. I'm not a very shiny object. In fact, my glasses aren't even shiny. It's also a non-metal. So if you ever want to know where you sit on the periodic table and you're not shiny, you're probably right here. You're a non-metal. The farther you go to the right, the more metallic. The farther you go to the left, the more metallic, except for hydrogen. Hydrogen is our one exception. Hydrogen is right here. They're brittle, hard, or soft. You can see them in so many different forms. They are not malleable. I can bend, but my bones don't. They are poor conductors. If you catch nonmetals, put electricity in nonmetals, they generally catch on fire. We are called resistors. We resist the flow of electricity. As you resist the flow of electricity, you turn that electricity energy into heat, thermal energy, or light. This is how light bulbs work. As you put electricity through those metallic wires, they hit a resistor. This is generally a non-metal. This resistor will start to glow and release light and heat because it is a poor conductor. Non-metallic oxides are acidic and covalent. We form covalent bonds. We like to form acids. They form anions, so nonmetals form anions by gaining electrons. And you have a little mix here, which are called the metalloids. They are similar to metals, but they also have properties of nonmetals. You can be a mix. They are the grayish brown instead of the orange. Now, your exit slip is of videos on 2.1. Homework, please read the pages. No annotations again are given virtually. I would heavily suggest it. When you're finished with your notes, you're going to go and do what we did earlier. Going to go turn to week 5 types of bonds. You're going to, let me click this now. Oh, whoops. I forgot to make this public. Might as well open it. So you see this. You're going to start assignment. When you're finished, just click record. Take a picture. Video your notes. Turn it back and forth. If you don't want to do it like that, just click upload media. If you want to just take a picture with your phone, you can do that here. Either one works for me. If you have a different way you would suggest and you want to turn it in, let me know. I'm pretty available. If you have any questions, please email me. I'm pretty just sitting around at the house. So just let me know. Have an excellent day. I will see you tomorrow with an explanation of what you're doing tomorrow, which I'm about to make. Once I figure out how. There we go.